All right, so in this video, I'm going to be going over FRQ number 1 from 2017. This is one of those 10-pointer FRQs. This is going to be similar to how one of your 2 FRQs is going to be when you actually take your AP exam. It's based more so on scientific method, more analytical than anything else. So this is one that you want to make sure you're feeling comfortable with. I'm not too sure if they're going to have you graph anything with this. I haven't looked at a whole lot of the logistics on this, but for sure being able to analyze the graph, and this is good to go over standard error of the mean. So let's take a look and read through this one. It talks about in flowering plants, pollination is a process that leads to the fertilization of an egg and the production of seeds. Some flowers are going to attract pollinators such as bees using visual and chemical cues. When a bee visits a flower, in addition to transferring pollen, the bee can take nectar from the flower and use it to make honey for the colony. Nectar contains sugar, but certain plants also produce caffeine in the nectar. Caffeine is a bitter tasting compound that can be toxic to insects at high concentrations. To investigate the role of caffeine in nectar, a group of researchers studied the effect of 0.1 micromolar caffeine on bee behavior. The result of an experiment to test the effect of caffeine on bees' memory of nectar source is shown in table 1. So here is giving you the information, and a lot of this is on stuff that we wouldn't cover in an AP class besides this scientific process. So don't let the logistics of nectar or reproduction of flowering plants or anything like that scare you off. I am pretty confident that your first one will look very similar to something like this, to where they're going to have you just analyze it. So let's make sure we feel comfortable with this. So this is giving you 2 groups. You have your control group and then the group that was given caffeine. So I know it's not asking for it, but you want to just make sure that you can identify that this is your variable, right? This is what you're able to change, adding caffeine. That is the variable that you're looking at, right? And what is your dependent variable? It's, again, not asking it, but your dependent variable is the revisiting to the flower. So basically what they did is they were measuring, okay, how did these bees actually, or how often did they actually come back? So the probability of revisiting this is shown here. So this is giving you the probability. Each thing that I'm circling is representing the probability. What I'm underlining are going to be the standard errors of the mean, all right? And it looks like it's giving you at plus or minus 2 of the standard error of the mean. So these are really low values. It's not asking for it right now, but just remind you guys, the lower the standard error of the mean is, the more consistent your data will be. So that's all looking pretty good. So let's see what we actually have to answer on this one. And I kind of already set it up just to kind of save time for this video. So let's take a look at this. It says on the axes provided, construct an appropriate labeled graph to illustrate the effect of caffeine on the probability of bees of revisiting that nectar source. Okay, so let me go back here and just edit this a little bit. So I just want to kind of erase that. Sorry. All right. So one thing that you have to be able to understand is that really there was 2 groups, right? You had your control group and your caffeine group, and they took 4 sets of data: the probability of revisiting after 10 minutes and the probability of revisiting after 24 hours, okay? So when you guys graph this, or even if you just had to analyze a graph, let's make sure you feel comfortable with this. So 2 groups, the control and the caffeine, and they took the measurements at 10 minutes and 24 hours. Again, what I've circled, those are the probabilities, and then what I'm underlining is the standard error of the mean, all right? So like I said, identifying your independent and dependent variable is makes life a lot easier. So this is essentially your variable. Your dependent variable is revisiting the flower. Sorry, that got erased. So revisiting the flower or the nectar source. So when you're setting it up, typically all graphs are going to be worth 3 points. The dependent variable, like we mentioned, was memory, the probability of revisiting the nectar source. And here's my 4 data entries. I have the control group at 10 minutes, the caffeine at 10 minutes, the control at 24 hours, and then the caffeine at 24 hours. So let's remind us how to graph these, and it shouldn't be too bad. So, whoops. Going back. let's erase that real quick, sorry. Okay, so I'll do the control group first, both of them, all right? So the control group at 10 minutes, the mean is at 0.72. So the control group, 10 minutes, I'm gonna plot this right at about 0.72. And I have to graph the error bars appropriately. So the standard error of the mean is plus 0.09 and minus 0.09. So basically if I added that 0.09, so 0.72 plus 0.09, that's going to take me all the way up to 0.81. And that's going to take me, that's on the adding. If I took that away, 0.72 minus 0.09, that's going to take me down to 0.63. So that's where I got to draw my error bars to. Now it's already doubled, so I don't have to double that because it's giving me at 2 standard error of the mean. So my highest I got to go up to on this one is going to be to 0.81. So it's going to go a little bit past the 0.8. And it's going to go all the way down to 0.63. So that's going to take me down right there, all right? So I can just go through and graph the rest of these out real quick. Why don't I just keep it with the control at 24 hours? The probability of revisiting goes down to 0.41. So that I'm just going to plot that one over here. So there's going to be my 0.41. And my error, it goes up. When I added that 0.07 to 0.41, that's going to go up to 0.48. This one is going to take me down to 0.41. Take me down to 0.34. So I have to draw my error bar up. If that's 0.4, really small, up to 0.48. And then it takes me down to 0.34, all right? So those two are looking good. Let's kind of divvy up now and do the caffeine group. We'll do the green now. So 0.83 is my mean for the 10-minute one, and 0.78 is going to be the next one. So 0.83 for my caffeine at 10 minutes. So I'm going to find that point and do a little bit past 0.8 here. And it's going to be at 0.07 is my error. So when I add that all the way up, it's going to go all the way up to 0.90. And it's going to go down all the way. When I subtract that error, it's going to go down to 0.76. So I need to graph my error bars up to 0.9 and down to 0.76. All right. And the last one is going to be 0.78, and with the error of 0.08, this is going to be the last one, so plus 0.08. It's going to take me up to 0.86. When you add it, when you remove that from the 0.78, this is going to take me down to 0.7. So the mean for the caffeine at 24 hours is going to be at 0.78. So the mean here is going to be at 0.78. So right around here. The error is going to take me up to 0.86. That looks to be good. And it's also going to take me down to 0.70. So looking like that. Okay. Now let's take a second and just evaluate this data that it's given us now. So this would have gotten you the 3 points, and you could have had these all flip-flopped because they're, it's data that's grouped. I did it where I had the control at 10 minutes, caffeine at 10 minutes, and then the control 24, caffeine 24. You could have had also control, and then caffeine. Either's fine. So when you look at these, we now got to take a second. This would have got you your 3 points for this one, but when it says based on the results, describe the effect of caffeine on each of the following. So the short term, at 10 minutes, the memory of a new nectar source. So if I were to just compare these two groups of data, right? Control group at 10 and caffeine at 10. The caffeine's mean is a little bit higher, but when you look at the error bars, there is some overlap. So I would state that there is no difference. So, and statistically, you have to state that you cannot claim that these are different enough because there's that error, in those error bars are overlapping. So that is going to earn you, if I look at the rubric right in front of me, yeah, it does look like short-term caffeine does not affect short-term memory. So caffeine, no difference. And that's, again, because the error bars overlap. Okay, you cannot state that those two are different enough, okay? So that earns you 1 point on that one. Now, for long-term, 24 hours, now when we look at these two groups of data, yes, the mean of the caffeine, it's showing that the mean is definitely much, much, much greater on the caffeine returning 24 hours as opposed to the probability of returning in the control group. Not only is the mean much higher, but when you look at those error bars, they don't even come close to overlapping. So you would make a claim based on the results describe the effect of caffeine. You would say that the caffeine does increase the probability of returning. Yeah, and that's basically all it looks like what you guys had to state there. So really, that's going to earn you that point. So we're up to 5 points on this FRQ. So you got the graph dialed in, that justification of that. So let's move on to C and D. C says design an experiment using artificial flowers, so not real flowers, to investigate potential negative effects on increasing caffeine in nectar on the number of floral visits by bees. So basically they're taking the actual viable and real flower out of the equation, and we're just looking at how does caffeine impact the bees. So it's asking us to identify the null hypothesis. It's asking you to identify a control treatment and the predicted results that could be used to reject it. All right. So yeah, it's pretty simple. So in this case, the null hypothesis, again, how to write a good null. It's basically stating whatever your variable is has no impact. So you would say having caffeine has no impact. So increasing caffeine is going to have no impact on if they're going to revisit. So again, I'll just circle the caffeine is your variable. So there's your null. A control group would be the bees without caffeine. So in terms of that, or not bees, excuse me, nectar with no caffeine. So we will just say no caffeine in this one. So that's going to be your appropriate control group. And what would be your predicted results? So a couple of things on this one that is relatively interesting when I look at the rubric. Having the rubric in front of me, it's telling us that the number of floral visits by bees is different when you increase caffeine, or the number of floral visits is going to be different than the control. And again, the data told you, so basically it's just going to be increasing revisits with caffeine. So basically a restating of what you saw with the data. So floral visits is going to be different with increasing the caffeine concentration. So it's just all in how you worded that in your answer. But each one of these is worth a point in the sense that the null hypothesis is worth 1, identifying the control is worth 1, and predicting what's going to happen is worth 1 point. So that one is looking pretty good. Nothing I think that is too crazy. So let's just wrap this one up. So for part D, D looks to be worth 2 points. So researchers found that nectar with caffeine tends to have a lower sugar content than nectar without caffeine. So basically the nectar with caffeine has lower sugar content than nectar without caffeine. All right. Plants use less energy to produce the caffeine and nectar than they do to produce the sugar. So propose one benefit to the plants that produce nectar with caffeine and lower sugar content. Propose one cost to the bees that visit the flower plants and produce nectar with caffeine. Okay, so interesting wrap up on this one. So let's kind of pull out the key information that they're telling us on this one. Again, I read these things 2 or 3 times just to make sure that it all clicks with you. The nectar with caffeine is going to have a lower sugar content than nectar without caffeine. Plants use less energy to produce the caffeine in nectar than they do to produce sugar. So basically it's stating that it's easier for the plants to make the caffeine in the nectar than to produce the sugar in the nectar. So it's easier for the plant to actually make the caffeine. But you got to also think about it too at a much bigger picture. Well, again, what's the point of having that sugar? Well, it's cell respiration. I mean, things are going to need that sugar. So it's asking us to propose one benefit to plants that produce nectar with caffeine and lower sugar content. So a couple of things for the plant, the benefits to the plant. It almost even tells you it directly in that problem itself. The benefit is they have more energy available for other uses because it's not wasting energy. I don't want to say waste, but it's going to have more energy stored because it's not making all that sugar in the nectar itself. But also, too, what is the proposed benefit of the plant? Not only that, but as the data told you, you're going to increase revisiting pollinators. Right? So those are the two. Either or would have gotten you the point. So again, it doesn't take much energy. That almost tells you in the problem, but that's the benefit to the plant. It doesn't have to take a whole lot of energy to store that. Or you could have stated that it increases the revisiting of those pollinators. So that's the benefit of the plant. So what is the one cost to the bees? All right. So a couple of costs to the bees. There's a ton of things that it looks like the rubric is going to tell you that'll earn a point. One thing just off of the top of my head would be, well, if bees are going to be revisiting it a bunch, they're going to be overworked. So you could even state something along the lines that the bees are going to use too much energy. I mean, that to me is the most realistic response. And it tells you in the rubric, you could have stated many, many, many things. It has like 4 different really broad things. It could lead to less honey production, but that's a little specific. Nothing that I would really anticipate any student really pulling out unless they had a good foundation about bees. But in terms of that, they're revisiting more flowers. That's going to reduce they're just going to be using more energy. The more caffeine, the more likely they're going to be coming back to it. So the bees are going to get less energy from that because there's just caffeine and not sugar. So that would be that last point. So overall, it's a pretty lengthy FRQ. It's a 10.1. You guys will have one that'll be similar in fashion to this in terms of structure, A, B, C, and D. So I hope that's helpful. That was the FRQ from 2017, number 1.